Welcome back to another video from Insectix Android Application Penetration Testing course. In this video, we're going to discuss Android architecture. So if you look at the presentation, there are various different layers in this Android architecture, and it is pretty evident that Android is built on top of Linux kernel. So let's begin with this bottom and let's go towards the top. Right, so to start with, Linux kernel is the core operating system for your Android. It takes care of memory management, process management, drivers, and other similar things. And coming to the libraries, these are one of the most important components of your Android system. If you see this SQLite, basically when you are getting SMS or when you're saving contacts, all those are actually being saved in your Android device inside something called SQLite database. And for your SQLite database to work with your Android, you need these libraries. And similarly, you have WebKit. When you open your device and when you open your browser and you browse something like www.google.com, it is getting rendered as a HTML page, and that is possible because of this WebKit library. Similarly, SSL is to provide security. OpenGL, ES, SGL, or these are for graphics, right? So similarly, there are a couple of other libraries which are required for few things to work in your Android. So this is the significance of this layer library, and we'll come back to this Android runtime in a couple of minutes. This is the most important, and this is the heart of your Android architecture. And the next layer is application framework. Application framework is something like an API. So if you are from development background, you must be aware of something known as application programming interface. It means this provides an application programming interface for your applications layer. So what it means is, let's say you want to develop an application which can read the location of the user who is using your application. So do you really need to write everything to read the location? No, because Android is already providing some APIs for you. You can simply access them to read the location of the device. So it is something like printf. If you say printf, you're not defining it, right? That is defined somewhere in your header files. That's the reason why you're including something like stdio.h. So similarly, all the important functionalities have been given as APIs. For example, notification manager, content providers, window manager, activity manager, telephony manager. For example, you want to read the IMEI number of your device. You don't need to write the entire program for reading this IMEI because Android is providing API. You can simply access this telephony manager API to read IMEI number of your device in your application. So that's basically your application framework is. And the last one is applications layer. This is the layer which you can physically feel. You say contacts, phone, browser, these are the applications that we really interact with in your day-to-day life. And this application layer can contain applications that come pre-installed by Android, or the applications that are being installed by the end user. So it can be any application. It could be the application that is downloaded from the Android market, or it could be the pre-installed one. So any application belongs to this applications layer. And this is what we have missed. Core libraries contains all the libraries again that are required for your Java programs or Android applications to work. But this Dalvik virtual machine is something that is important to understand. I'll just quickly show you a figure to make you understand this. If you see this, this is a very simple illustration of what this Dalvik virtual machine is. Generally, when you write a simple Java program, let's forget about Android for now. Let's take a very simple example of a simple Java program. Right, so let's say I have written a Java program. Generally we do save it as .java file, and to compile it we have to use a compiler called javac, and the moment we give this .java file to this compiler, which is javac, it generates a bytecode which contains .class file. Right, now we have to give this you can run this directly in your Java virtual machine, or you can convert it into a jar file and then run it in your Java virtual machine. So this is the basic process for your Java programs, but this is for systems, for computers. In case of mobile devices, you cannot run your mobile applications inside Java virtual machine. You have to optimize your programs for your in such a way that they should work in your mobile devices, right, which are smaller in size, and battery backup is when compared to regular computer systems, your mobile devices are different in terms of battery power and other couple of other things, right? So let's now understand how these programs are compiled for Android. Again, we do write programs in Java. Generally, all the applications that we are writing are developed using Java. So we write a simple Java program, and then we give it to javac. That's again common, just like your regular Java program. It generates a .class file. It is similar so far. Till here, it is same as what we have done with the regular Java program. But now we need to run this class file in an Android device. So we need to optimize it in such a way that it works easily in any Android device. So we need to give it to something called dxtool. So this dxtool converts this class file into something called .dx, which stands for Dalvik code. So whatever the class file that you have will be converted as .dx file, which is an optimized version for your Dalvik virtual machine. So rather than running your programs in Java virtual machine, you are running them inside something called Dalvik virtual machine, which is optimized for embedded devices like your Android mobile phones, right? So this is all about your Dalvik virtual machine. So every application that you are developing will be running inside this Dalvik virtual machine, right? So that's all I have in my mind for this video. In the next video, we'll see even more details about your Android lab setup and how you can go about building your own Android applications, right? So thanks for watching this video. Thanks a lot.